So we're starting our new unit today on ratios. So about our next 35 lessons are going to be on this new term, ratios. So we're going to explore today what a ratio is. Our I can statement for the day is, I can understand that a ratio is an ordered pair of non-negative numbers. We should remember from before that ordered pair was one of our vocabulary words, and we know what negative means, and we know what that prefix non means as well. So remember, an ordered pair is when I have an x value and a y value, and I can use them to graph them on a coordinate plane. So maybe the coordinate 1, 2 would be over 1 and up 2. The point here is that pair refers to two numbers, and order means that there's a specific order. That one number, in this case 1, 2, has to come first. Our second word that we have is negative. We know that negative is a number to the left of 0 on a number line, so that would be all of these numbers over here. And then that prefix non means that it's going to be not negative, so it would actually be referring to all the numbers on the right side. So a non-negative number is when our number x is greater than 0. So let's look at our next problem. So here's our first example with ratios. The co-ed soccer team, so co-ed means boys and girls mixed together. So we have boys and girls. So this co-ed soccer team has 4 times as many boys on it as it has girls. We say that the ratio of the number of boys to the number of girls on the team is 4 to 1. We read this as 4 to 1. How can we create a table to show this? Remember, a table in math is a way that we organize. So I need to create a table that shows how I can organize my boys and how I can organize my girls. So what I'm going to do is I need a table that shows boys and a table that shows girls. And then I'm also, just to keep track, I'm just going to make another one that is for the total. So my boys plus my girls. I'm going to look back, and here it says that the ratio of the number of boys to the number of girls on the team is 4 to 1. Not quite sure what that means, so I'm going to go back and reread this first sentence. It says it has 4 times as many boys. So that means there's 4 boys and 1 girl. So there's a total of 5 people total. So this is how I show, using the table, my boys to girls. So now we're going to take it another step further. What are some of the ratios that show 4 times as many boys as girls? A ratio of boys to girls of 4 to 1. Well, this word times means I'm going to multiply. So let's just check. What if I multiply 4 by 2? And remembering my equations, whatever I do to the left, I have to do to the right. I would get 8 and 2, and this would become 10 with that 8 plus 2. That's still keeping my ratio of 4 times as many boys to girls. If I break them up into groups, 1, 2, 3, 4 boys and 1 girl, 1, 2, 3, 4 boys and 1 girl, I see there's 8 here and 2 here, but I still see that's a ratio of 4 to 1. There's still 4 times as many boys to girls. I could do the same thing. I can multiply this 4 by 3 and this 1 by 3, and I would get 12 boys and 3 girls. That's still going to hold my ratio of 4 boys to 1 girl. Another 4 boys and 1 girl. Another 4 boys and 1 girl. And then my total, of course, would be 15. Let's check our next one. Suppose the ratio of boys to girls is 3 to 1. Create a table that has 3 rows using the given ratio. So remember, a row, here's 1 row, 2 rows, 3 rows. My rows are up and down. So I need to create a table that has 3 rows. So let's start there before we even get to the problem. I'm going to have boys, girls, and then this one's just going to be my total. So it says I have a ratio of 3 boys to 2 girls. So I have 3 boys, 2 girls, and that would be 3 plus 2 is 5. Then what if I have, here's my 3 to 2 picture. What if I have 6? I'm just going to double it, multiply it by 2. 3 boys, 2 girls. There's another 3 boys, so I need to add 2 more girls. I'm left with 4 girls for this one with a total of 10. Then I'm going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, matching this 6 to 4. I'm just going to add another column. So I have 3 more boys, 1, 2, 3. Whenever I have 3 boys, there's 2 more girls. So here I have 9. Here I have 6. That's a total of 15. I have my 3 rows, and I still have this 3 to 2 ratio. Whenever I have 3 boys, there's 2 girls. 3 boys, 2 girls. 2 girls, 3 boys. So I'm always keeping that ratio in the same portion. Okay, so here's my table again. Let's look at this question. Why can't I say there are 3 times as many boys as girls? What would my multiplicative value have to be? Let's really take a look at what this question is saying. Why can't I say there are 3 times as many boys as girls? Well, if there's 3 times as many boys as girls, that means that whenever I have a number here, I should be able to multiply it, and that would give me my boys. So this should be 6 boys. But when I look over here, I see it's only 3. When it's saying 3 times as many, that means I'd be multiplying my number of girls times 3. If I see it shouldn't be that. So I'm going to figure out, what can I do to figure out what my multiplicative value is? So basically, what do I multiply 2 by to get 3? So I can actually write, since we finished our equations unit, this expression, 2 times what? Equals, and we know it should equal 3. So here we're using that equations that we just finished up. 2 times x equals 3. I know my first step is I copy. So I'm going to copy this problem. 2 times x equals 3. Then I perform the inverse, or the opposite. Here I have multiplication. Opposite multiplication is division. So I divide left side and divide the right side. Divide by whatever number is with the variable. So here I have a 2 with the variable. So divide the left and the right by 2. And then my last step is I solve. My 2's will cancel out. I'm left with x equals 3 halves. So that is my multiplicative value, or what I multiply 2 by. 2 times 3 halves actually equals 3. If you don't remember, go back to how we multiply fractions with whole numbers. So there are 3 halves as many boys as girls. Can you visualize 3 halves as many boys times girls? Well, we have those pictures to always help us. We can make a picture. Here I have 3 boys and 2 girls. So 3 halves, or we can also say this as ratio is 3 to 2. Can I make a model that shows 3 halves as many boys as girls? Yeah, that one's really easy. I can use a tape diagram. Here we have 1, 2, 3 boys and 1, 2 girls. So it's still having that ratio of 3 to 2. Or remember, I can write it as 3 to 2. So my last question I'm going to look at is, what description makes the relationship easier to visualize? Saying the ratio 3 to 2, or saying there are 3 halves as many boys as girls? There's no right or wrong answer for this, but for me, this one is easier. They're saying 3 to 2, or writing it out 3 to 2. There's no right or wrong, but for me that's just easier. Saying 3 halves, it just confuses me because I think we have a boy, and then we have like half a boy, since it says 3 halves. So here would be 1 half, 2 halves, and then since I need 3 halves, I'd have half, and that just confuses me. So for me, I say this one's easier, saying the ratio. Okay, let's find the ratio of boys to girls in our class. Since you are not with our class right now, you are working on the computers, you're going to actually skip this part. So let's go to our next one. You're actually going to be skipping this as well. You're going to be doing some classwork on Socrative instead in a moment. What I do want you to do is you're going to see this problem on your Socrative, so I want you to pay attention as I go over it here. You're going to create your own ratio by looking around the room. Fill in the following sentence starter with your own ratio. My own ratio compares what? So look around the classroom and think, what can you compare? Well, an easy one is, I'm just going to compare people who are wearing shoes to sandals. So my ratio compares the number of people wearing shoes to sandals. And since I don't see any kids in class, since I'm guessing it's winter time, that are wearing sandals, I'm just going to guess that there are 25 people wearing shoes and there are 0 people wearing sandals. So my ratio will be 25 to 0. Alright, this one you're going to be doing on Socrative. So I'm going to have these questions on Socrative as well for you to type in your answers. But here's the model that you're going to follow. You're going to, though, be doing it by yourself. So you're going to use the words to describe a ratio that represents each ratio below. So my example is 1 to 2. There's no right or wrong answer, so you can pick whatever you want, but you're basically coming up with a real world situation that describes these ratios. So for the 1 to 2 example I have, for every 1 year, there are 12 months. So here's 1 year, and then within that 1 year, there's January, February, March, April, May, June, July, August, September, October, November, December. So I have 1 year, 12 months. So you are going to write a sentence for A's ratio, sentence for B's ratio, sentence for C's ratio, D's ratio, and E's ratio. And you're going to be doing this on Socrative. If you're not sure, come back and refer to this page when you get to that. Alright, we're almost finished. So, what are 2 quantities that you would love to have a ratio of 5 to 2, but would hate to have a ratio of 2 to 5? So, this is basically going down to, why does it matter if I say 5 to 2 versus 2 to 5? Well, look at this example. I would love to have a ratio of the number of hours of playtime to number of hours of chores to be 5 to 2. But I'd hate to have a ratio of the number of hours of television time to number of hours studying to be 2 to 5. So what this saying is if you have 5 hours of playtime, for every 5 hours that you play, you have 2 hours of chores. Oops, so I need to change that. I was going to put chores first. 2 hours of chores. That's an excellent ratio, I think. What if it was switched, though? What if you said order doesn't matter? And so instead, you're kind of being lazy or careless, and you switch the 2 and the 5. You know, that's a big difference. Here you only get 2 hours of playing, and you'd have to do 5 hours of chore. So we can see that the ratio of 2 to 5, that's not equal. It's not the same as 5 to 2. So as we're working with ratios, you're going to have to be careful that you make sure you're putting the ratios with the correct number. Okay, so our lesson summary. A ratio is an ordered pair of non-negative numbers which are not both zeros. So we can't have a ratio of 0 to 0, but we can have a ratio of 2 to 0 or 0 to 2. They just can't both be 0. If you don't remember what ordered pair and non-negative are, go back to our beginning slide. A ratio is written as A to B, so using those two colons, or A to B with that little number, or with that word 2 actually written out. Indicates the order of the numbers. A is first, and B is the second number. Remember, order does matter, going back to this example right here. That order is important. Okay, and our last point is the order of the numbers is important to the meaning of the ratio. Switching the numbers changes the relationship. The description of the ratio relationship tells us the correct order for the numbers of the ratios. So this again is emphasizing this first point, that order matters, and it's emphasizing this example that we did here. You need to make sure you're putting your ratio numbers with the correct parts. Alright, what you're going to do is you're going to head to Socrative, solve those problems. When you're finished on Socrative, remember the room number is Corbett 6 again. When you finish those, you're going to go on Khan Academy for math. Remember, all of the extra credit to get that letter grade increase is on the door leading to Mr. Kelly's room, so you know which ones to work on. If you need help, check with Ian, and good luck. If you don't pass your Socrative quiz, please go back, try it again. If you're not sure or you need help, I'll be looking at your Socrative to come over and assist if it looks like you're struggling. Good job.